Alright, welcome to Jaka Quantics. Now in this tutorial I'll be putting us through how to measure piling works. And piling works is in section 1.7 of the BESMM 4R, section 1.7 of the BESMM 4R, Building and Engineering Standard Method of Measurement 4 Revised. Alright, so we'll just go straight. If you reference your BSM4R, you see takeoff list, concrete, reinforcement, disposal, and testing. Of course, this is your measurement sheet, your takeoff sheet. You have the times in dimension on the square, and then of course you have the unit. Alright, so we have a diagram here of a pile. Now it's a pile 600 mm diameter, total number is 206. Alright, now the reinforcement in the pile is 8y16. 8 number, y means high yield, 16 means the diameter, 16 mm diameter reinforcement, of course high yield steel bars. That's what I just put there. Alright, and the stirrup is y10. The length of the pile is 18,000 millimeter, and here is 600 mm. So this plus this gives us 18,600 mm effective total length. Total length is 18,600 mm. So this is the details about the piles. Alright, so if we pick the first item, this is concrete. Now if you notice here, I didn't put bringing into plant. I'm not answering any question here, right? But if it's an exam and they say, okay, measure piles, you're measuring piles, of course you need to bring in your plants to site and allow for taking them away from site. Alright, so please let's take note of that. So but I'm not saying anything, I'm just dealing with piles. Alright, so we have the concrete item, right? This is the concrete item, say grade 30 concrete. Now the unit for concrete in the BSM4R for piling is in meters. Alright, it is in meters. However, you need to explain in details what that particular item contains. Like here you see board piles, in situ concrete, or in situ concrete board piles, 0.6 meter diameter, 17.7 meter length board, 18.6 meter length maximum length piles, maximum length piles, 206 numbers, right? Then the code reference. This is basically what we have. All right, now this is the concrete. We have 18 meter and we have 600 18 meter and 0.6 meters. Now of course the pouring of the concrete, not all these 18.6 meter will go into the ground. There's what we call pile head. Of course, if you're conversant with pile head, call pile head. Maybe like 1 meter will be above the ground, or 900 or 800 as the case may be, will be above the ground. It's called pile head. That is what will enable the connection of your pile cap. If everything goes into the ground, then there will be nothing for your pile cap to connect with. Alright, so that's why not everything will go into the ground. See how I illustrated it here. Length of pile is 18,600 mm, less pile head that connects with the pile cap, 900 mm. So we have the 17.7. So this is the length. This is the length that will be going into the ground. But the total length of concrete we are casting is 18.6 meters. Take note, but 18.6 meters, not all of them goes into the ground. Alright, so this is this concrete. We have described the concrete. This is the reference. You can confirm, you can reference, you can cross-check also in your BSMM4R. Total length is 18.6. Total number is 206. This is measured in meters. That is concrete. As simple and as straightforward as that. I close it up, bracket. Alright, then the reinforcement. Of course, we already told you the reinforcement is 8 number y16. That is, the vertical ones is 8 number y16, while the one spiraling, that's the link, is y10. Alright, so this is basically what we have. And of course reinforcement is measured in tons. Whatever calculation you do, you have to show that it is converted to tons, especially if you're preparing for an exam. But of course if you're working in your office, of course you know, if you're preparing the bill, of course it's in tons. But you may have a bill you need to price. If it's in kg, you put it there in kg. If it's in tons, you put it there in tones, but according to the BSM-4R, it is in tones. Please let us take note. All right. So the total reinforcement is going down 18 meter. Of course, you see the shape of this place. So the reinforcement is going down 18 meter. So we have 8 numbers of them. We have 206 number piles. Right? This is 206 times 8 numbers. We have 18 meter length for each of them. As simple and as straightforward as that. That is the reinforcement for that. Now we'll go to the links. Okay, I explained something here. I said for us to convert to tons, right, we have to multiply by the weight in kg per meter of 16 mm of the reinforcement. And I said there's a formula for calculating the weight in kg per meter of any reinforcement: diameter squared over 36 times 0.222. Diameter squared over 36 times 0.222. I gave an example here. We have 16 mm. So it is 16 times 16. That's diameter squared, d squared. Right? I divide this by 36. I multiply by 0.222 by this formula here. Alright? That's how we arrived at it. To convert it to tons, from this, now here it is in kg. If I multiply by this factor, it is in kg. Because what I just is kg per meter. Now by this, I convert to tons. I convert to tons. By divide by 1000. Of course, 1000 kg, I wrote it here, is 1 ton. Alright? I hope you can see this. Let me leave this. Let me not remove it yet. Alright. So we go to the links now. Now the links, they were so it is Y10 at 200 millimeter center to center. Now, of course, the question is how many of them am I going to have? Because I have 18 meter length reinforcement. How many am I going to have there? Alright. All I need to do is to divide the total number to the length by the spacing. The length of the total reinforcement going into the pi divided by the spacing. Okay, like I wrote this. I wrote it as number of length equals total length divided by spacing plus 1. Right, because it is spacing. Where you're starting from, you are going to start from there with 1. Alright. So here we have total length is 18 meter. For me to know how many numbers, this is 18 meter. The 18 meter here is 18,000 millimeter divided by 200 plus 1. Number of link equals total length divided by spacing plus 1. That's how we got 91 total numbers. Alright, now the link itself, the diameter of the pile is 600. Right, diameter of the pile is, of course, this is already inside reinforcement. When I mean diameter, this is what I'm talking about. You see it here. This length is called the diameter. Right, it is 600. We are down 600 mm. For me to see it, I have to less cover, concrete cover on both ends, 25 mm, 2 times 25 mm. That gives me 50. If I less, I have 550. Then I multiply by pi. Reinforcement is pi d. Money reinforcement. Circumference is pi d, 2 pi r or pi d. Alright, so this is the d, which is the diameter I've calculated, and I multiply by pi. That gives me 1727. Right, so I add bend. Of course, when you tile links, whether in circular column or square column or rectangular column, you have to tie it so that they can lap each other and for proper tightening. Alright, so I add bend 75 mm. It could be some use 150, some use 100, some use 200. Right, so 75 mm, that gives me 1877, so 1.877. Right, that's what you see here, 1.88. Right, okay. Of course, the total number, we have 91 numbers which are already calculated times 206 total number piles we have there. So this is how you measure the links. It is as if any spiral column, it is the same method. Alright, and the piling also is the same method. Alright, so this is how you measure the links also. Alright, so we close out. Now our next item will be disposal. Of course, the sand you remove from the, because of the boring process, because you have to dispose out of site. You have to remove out of sides. And of course, if you look at this place here, this diagram here, it should be in twofold. This is one, right? This is one. The straight end is the one, right? The bent end, that's okay. The cylinder, right? The cylinder part is one, which is this, and we have the cone part of it, which is this, which is this. Did I get it? I think I got it. Which is this part of it also. All right, so this is basically what we have here. That's what we want to dispose. So the effective length of what we want to dispose for the cylinder part of it, as a straight part of it, is, remember we said 900, about 900 is above the ground. All right, 900 is already above the ground. So 18,000 divided by minus 900, that gives us 17,100. Right, that's for the straight part, for the cylindrical part of that particular board pie. It is 17, right, 100. Of course, it's a cylinder. A cylinder, formula for cylinder is pi r squared h, volume of a cylinder, right? Pi r squared, that's what I wrote here. Let me put it in red. Pi r squared, did I put the others in red? Pi r squared h. Alright, so that's what we have here. Pi is pi, r is radius, 600 divided by 2, r equals 600 divided by 2, that is the r. That's why you see 0.3 here, 0.3 by 0.3 by 17.1. Now of course, here is the pi, the pi is there, 3.142, right, times 206 numbers. So I have 647, right? 206 number, which is the total number of piles we have, then multiply by the pi. So this multiplied by the pi gives us the volume of sand to be removed from here. Now you can see I didn't square. I'll tell you why I didn't square. Now for the cone shell shaped area, we'll do it also. Now of course we use the volume of a cone. Alright, we use the volume of a cone. Volume of a cone is 1/3 pi r squared h. Now you see QS and maths, they go hand in hand. Pi r, 1/3 pi r squared. The same thing I'm going to do here. R is 600 divided by 2, diameter over 2, right, which is what I have here. H is the depth, which is the 600 mm. Kuban Kabani. Yawa. To. Alright, so this is basically what we have. So the same, this by this pi r squared, this and this is the r squared. This is the depth, 600 mm, which is 0.6. Alright, multiplied by the total number, which is 206, times 1/3 times pi. You see it here, 1/3 pi. See the 1/3 here. Alright, this is the pi, this is total number. Why you're seeing it a whole number? Because I round it up. I have done this in one of my videos, right? How to round up, how to round down, how to do significant figure, how to take it to a whole number, right? I rounded it up to a whole number. That's why you're seeing this. Okay, maybe you should be seeing 647 point something or so. All right, so this is how you calculate the disposal, the volume of sand that is being removed during the boring. All right, so I close it also. That's called bracket. Now the test, of course, you need to test your pile. After the pile and everything has been done, you need to test before you start making your pile cap and continue with your work. So you need to, of course, do a pilot test for 306 number per board piles. Then you need to do integrity test also. All right, for determine the integrity of the piles to carry the load that is coming on it, and also with the load test also. Okay, this is basically how you measure piling works, right? Using the BASMM 4R. Now all these I've done here for a civil engineering measurement. I think in the CSMM part of the BSM 4R, I think it is there. No, it's a number item. Concrete is a number item. I don't know if reinforcement is inclusive, but it's a number item, which is way more easier compared to what we have here. All right. Okay. Now you see here, I prepared a draft bill. That is why I didn't square. If you're preparing a draft bill, say for an exam purpose, you don't square. You don't square. If you say prepare a draft bill, You don't even need to, you don't need to square. All you need to do is do the takeoff. This is the bill here, right? In a draft bill, you don't have quantity, you don't have rate, you don't have amount. You don't have quantity because you didn't even square. If you didn't square, how do you want to have quantity? Right? You only have units. Now, of course, this is the concrete grade 30. I describe it. This is the BSMM 4R reference code. Right? The reinforcement also is in tone. You see the unit there. Of course, this one also. Let me put this one unit also. Is also in tons. Right? Disposal is in cubic meter. Is in cubic meter. Remember, with volume of cylinder, volume of cone is in cubic meter. While testing is an item. Alright, so this is how you prepare a draft bill of quantity. No quantity, no rate, no amount. Right, I hope this video helps you academically, professionally, and if you're preparing for any exam. Alright, this is Chaka Quantics. I'll see you guys in the next video. Thank you.